Hey everyone, I know it's been a little while since our last one of these videos, but here we are again. Today we're going to talk about the history of scientific models of the atom, and we are going to compare some of these different models, look at some of their pros and cons. So, way back in ancient Greece, they decided that all matter can be broken into smaller pieces, but eventually things got as small as they could go, and they figured once you hit about a grain of sand, then that's probably about as small as things can go. You can't break a grain of sand. And they used the word atomos, meaning indivisible, to describe this phenomenon. And that is how we got the word atom that we currently use today as our smallest state of, our smallest matter. And that model stuck with us for a very long time until in 1803, John Dalton appeared and proposed not only was all matter made of these atoms, but the atoms of the same element are identical. So all helium atoms are the same, all carbon atoms are the same, all gold atoms are the same. And he said that atoms of different elements would have different sizes and masses, and decided that all atoms were basically solid spheres, kind of like billiard balls. So this model for atoms is nice and simple and is easy for us to do models with. I mean, we still basically use this atom when we're doing particle theory. But we know there's a lot of flaws with this model right here because, well, we know that not all atoms of the same element are identical. That is what isotopes are, and we're going to get into that in the coming weeks with the curriculum. Almost 100 years later, Thomson comes along and adds some alterations to this plan. He says that they are solid spheres, yes, but there's more to it. And he won the Nobel Prize for his discovery of electrons. He said that these electrons were negatively charged particles that were scattered throughout the sphere, and the sphere itself was positively charged, giving the whole atom a neutral charge. This is known as the blueberry muffin or plum pudding model, because basically we're saying the electrons are like the blueberries in this muffin here. They are interspersed throughout it. You can see some on the edge, you know there's more inside, and they are all negatively charged, and the muffin itself is positively charged. So this one is slightly more accurate than Dalton's spherical model, because we now know that there are charged particles here, and it's still relatively simple, but it is still not the best model we have. A few years down the line, we have Ernest Rutherford. He created the nuclear model for the atom, which is the model that most of us are used to seeing on TV shows like The Big Bang Theory. He based these off of observations from his gold foil experiment, which we will talk about on the next slide. And he said that the electrons are placed around a positively charged center, that most of our atom here is actually empty space. So here was his experiment here. He had an alpha particle emitter, which is essentially just a type of radiation. electromagnetic waves, that he was shooting at a piece of gold foil, so just a very thin sheet of foil. If the Dalton model was correct, and atoms were solid spheres, then they would go around the spheres most of the time because the spheres were small and there would be gaps. And, occasionally you might hit a sphere and come to a stop. But he found out that's not actually what he was seeing when he did this experiment. The radiation was getting scattered all over the place on his detecting screen here. Most of it went straight through, but a lot of it spread out. So this to him meant that most of the atoms were empty space that this radiation could just go straight through. But every once in a while, it would hit something that was tiny and be reflected, sometimes almost coming right back, sometimes getting deflected off at weird and wonky angles. Therefore, atoms had to be composed of mostly empty space. Niels Bohr built on this slightly. He still had our atoms orbiting a positively charged center, but he put it in a slightly more orderly fashion. This is referred to commonly as the planetary model because it has electrons orbiting a positively charged center like a sun. So it's almost like planets orbiting in our solar system. But again, that is not the most commonly accepted one these days, but it is the one that we focus on because it's the easiest one to model. In fact, we have Erwin Schrödinger's model is the most readily accepted one, but it's the quantum model and is very complicated. So the planetary model combined with discoveries of Chadwick is what we actually study in GCSE level courses. So James Chadwick in 1932 discovered what became known as the neutron. He basically looked at all these atoms and said, these are a lot heavier than they should be based on what the protons and electrons that are in them. There is clearly something else there that has to be making up this weight. However, he also noticed that atoms are neutrally charged. They don't have an overall charge. So whatever this other particle is has to be neutral because the protons and electrons already balance out. And this became known as our neutron, but it was really hard for him to test for this because, well, how do you test for something that's so small? Even the most powerful instruments at the time can't see it, and it doesn't have a charge, so it can't be detected the same way protons and electrons were. And it was also done using tests involving radiation. So basically, again, he had an alpha particle transmitter, very similar to in our gold foil experiment, but rather than firing them at a piece of gold, he fired them at a sheet of beryllium here, which he found out was knocking loose particles. But the neutrons that were fired off couldn't be detected like protons and electrons could due to their lack of charge. But when these neutrons hit a sheet of paraffin wax, they dislodged protons from there, and those could be detected. So basically, we knew that something was being knocked out from the paraffin wax that we couldn't detect. But we could use those things to knock loose other things that we could detect. And that was how we knew that neutrons existed. So here's a brief summary of our history of the atoms. Dalton with his sphere, Thomson with the plum pudding model, Rutherford with the nuclear model, and Niels Bohr with our planetary model, combined with the neutron discovery of Chadwick, is what we discuss most of the time. So this right here is the most important one for high school level students to understand. So in coming videos, we are going to talk about how these electrons fit in within these orbitals and all the rules that come with placing them. So thank you for your time, and we hope to see you again.